Our first example is, what is the equation of the curve that is the locus of all points equidistant from the 2 points 5, 3, and 2, 1? So to solve this one, first thing that we do is we will plot the points and draw the locus of all the points equidistant from the 2 points 5, 3, and 2, 1. So we'll plot first, or you will locate first the given 2 points. So for 5, 3, x coordinate is 5. 1, 2, 3, 4, 5. And the y coordinate is 3. That's 1, 2, 3. So there is 5, 3. Next is plot 2, 1. So x coordinate is 2, 1, 2, and y coordinate is 1. So point 2, 1 is located there. So we'll find the equation of the locus of all the points equidistant from these 2 points. So if we will assume the point that is equal in distance from these 2 points, so assuming it's there, since this distance is equal to this distance, or here, this distance is equal to that distance, so it's equidistant. So this point is equidistant to the 2 points. Or since we don't know yet the coordinates of this point, so we'll just assume that this is x, y. So if we will draw the locus of that points, these points, so we'll have a line. So the question is, what is the equation of this locus of all the points that is equidistant to these 2 points? So we'll find the equation of this line. So how do we find the equation of that line? So first, recall about the distance formula discussed to you. So distance formula is distance between 2 points is equal to the square root of x sub 2 minus x sub 1 quantity square plus y sub 2 minus y sub 1 quantity square. Okay, so that's the distance formula. So condition here, the distance from this point to 2, 1, say for example that's D1, is equal to the distance from this point to 5, 3, or say for example that's D2, since it's equidistant. So the distance should be equal. So equating that one, we have D1 equals D2. So we have distance between 2 points. We'll find the distance from this point and this point. That's for D1. This point and this point, the distance between that points, and that's D2. Okay, so using the distance formula for D1, we have the square root of x sub 2, so that's x sub 1, that's 2, x minus 2, quantity square, plus y sub 2, that's y, minus y sub 1, that's 1, quantity square is equal to D2. So D2 is distance from point x, y, and 5, 3. So that's x minus 5 square plus y minus 3 square. So that's it. Next thing to do is to square both sides. So squaring both sides, We'll square this one, then square both sides. So this radical sign will be cancelled out. So we have x minus 2 square plus y minus 1 square is equal to x minus 5 square plus y minus 3 square. Next is to expand. So expand this binomial. So we have square of binomial. So formula for square of binomial, that's a plus b quantity square is a square plus 2ab plus b square. So applying that one, so we have x square minus 4x plus 4. So that's the expansion of this one. So expansion of this one is y square minus 2y plus 1 equals, expand this one, that's x square minus 10x plus 25. Then expand this one, that's y square minus 6y plus 9. So after expanding, we will cancel and collect terms. So x squared, since x squared is located both on the left side of the equation and on the right side of the equation, so we will cancel that out. Then y square and y square. So what's left is negative 4x plus 4 minus 2y plus 1 is equal to negative 10x plus 25 minus 6y plus 9. So we'll transpose all the terms with y to the left side of the equation and all the terms with x to the right side of the equation. So we have negative 2y. So 6 here will be transposed there. So that's plus 6y is equal to 4x transposed to the right. So negative 4x, that's 4x. Then plus 4, that's minus 4. Then plus 1, that's minus 1. Then negative 10x plus 25 plus 9. So combine like terms, negative 2y plus 6y, that's 4y is equal to 4x minus 10x, that's negative 6x. Then negative 4 minus 1 plus 25 plus 9. Okay, so that's 34 minus, that's 29. So plus 29. Or simplifying that further, we have y is equal to negative 3 halves x plus 29 over 4. So that's the equation of this line. I hope you understand the first example.